Everyone, we want to welcome you back for another episode of Coffee Sessions. Feels like it's been a little while since we've been here, but we're super happy to be back. Demetrius is here with me as usual, and we have a very special guest today. We have Neal Lathia. Forgive me if I'm pronouncing that wrong. And Demetrius, what do we have in store for today?
We have a man of the world. Neal is with us. He threw me off, man. He was speaking like a true American, and then I'm like, "Oh, you're from the States, but what are you doing in London?" Nope, not from the States. He just has the accent.
I live in London. Grew up in Milan. Have family I was born in Belgium. He's all over the world.
It's good you remember it. Yeah.
Yeah, man.
People forget as soon as I tell them.
It's like when people ask your name and you forget like immediately after. It's like, oh crap, But I remembered because it stood out,
Yeah. It's not common. So anyway, Neal is I think the official title you have is the doer of cool things at Monzo with ML.
I like that. I'll sell it internally. Yeah. My title at Monzo is technically senior data science manager, but officially I sort of lead the machine learning team inside of Monzo.
There we go.
Nice.
And we really wanted to break down today what Monzo's been doing. I mean, Neal's been an awesome asset to the community, and really sharing his wisdom, and what you're doing at Monzo is really cool, Neal. So I wanted to talk about what your infrastructure looks like, what machine learning looks like at Monzo, and get into it like a little bit of a case study so that others can see what you're doing and how you're doing it and learn from it, hopefully learn from mistakes that you've had along the way, and learn from some best practices that you've come up with. And I think we should probably start though, because I'm going to be very transparent with you. Not that it matters for you. I know you have like no horse in this race, but I'm a TransferWise user. I also use N26, and I tried to sign up for Revolut, but they denied me. Like they couldn't. This is the irony of it.
Damn.
they couldn't. The machine learning vision. What was it? It was like the where it looks at your ID and says if you are the person you say you are. Like the computer vision algorithm denied me and said that they couldn't verify my identity. So I don't have Revolut, but I want to know, like, what does Monzo do and how are they different than all these other ones that I just listed off?
Yeah, cool. Great place to start. So Monzo is the biggest fintech bank in the UK. It's about 5 years old now, and we have probably close to 5 million customers now. How Monzo is different from these other companies that you mentioned, like TransferWise and Revolut, is that we are a bank. So Revolut is, as the last time I checked, isn't a licensed and regulated bank. And so Monzo is though. So the story of Monzo, when it was founded, they launched a prepaid card where you could load money onto your card and then spend it. And they used that time to develop their app, where you would get all of these really cool features that have now been adopted across the fintech industry and even in the bigger banks. So things like instant notifications for your transactions, things like being able to freeze your card if you've lost it, things like savings pots and automatic roundups. And then while they were working on that app, they applied and went through the very difficult, challenging process of becoming an actual bank. And I joined Monzo in 2018 when that license had come through, and they were going through the challenging part of like moving everyone from the prepaid, account over to the actual retail account that we have now. So it's been a long journey. When I joined Monzo just coming on 3 years ago, we had about 500,000 customers. Actually, that was one of the first things that I did for a little hack day, was an animation of our customer growth on YouTube. And fast forward 2.5 years, and we now have business banking. We have 2 different tiers of paid accounts that offer extra things on top of our retail account. And we just have this mad growth going on where thousands and thousands of customers are joining us every single week.
That's awesome. So cool to hear. And I'm wondering what kind of problems you're solving with machine learning at Monzo.
Great question. So I guess if I think about the broader industry and a lot of these companies that we look towards in terms of machine learning, a lot of them kind of have one killer application broadly. So like, for example, if you look at Spotify, and I know this is a bit reductive, right? But like Spotify music recommendation is their thing. That's where they're getting probably majority of their gains from machine learning. So if you look at a bank, it's not really like there's one killer feature that is gonna, be all of the machine learning that we do. So instead, and this is my experience of like being in a bank over the last 2.5 years, is that a bank under the hood is actually like probably like 10 different companies. So you have customer service, you have loans and overdrafts and credit scoring, you have financial crime detection, and then you have all of the cool stuff that you can ship into the app to improve the customer experience itself. So all of these areas have really interesting machine learning problems. The ones that we have been focusing on a lot for the last few years is on the customer service side, especially because with Monzo, when you want to get in touch with customer service, you do so via the app and you get in touch via chat. So that means we have a boatload of conversations, text, our customer service agents are replying via chat. And so we have a lot of problems that we want to solve to like mediate this interaction between the agents to help them help you, and also use the text data that we get to help customers help themselves and point them in the right direction. More recently, this year specifically, and this is a broader trend in the industry, when lockdown hit with coronavirus, there was a huge surge of different types of fraud, like people calling you up and pretending to be the police and saying you need to transfer all your money to a safe account. And this hit every bank. And so we spent a lot of time this year as well improving our controls there and shipping machine learning models to detect different types of payment fraud.
Yeah, and that is very useful. I'm sure lots of people thank you for that. But
yeah, for sure.
Yeah,
real quick, Demetrius, before you, I want to kind of dig a little deeper into some of the use cases. So I'm really curious. Why do you think that it seems like there's a lot of problems that you could frame as a machine learning problem in finance? Why do you think that is? Because I find that it's not always so straightforward for a lot of companies to just find. I'm sure they could find a way, but where it actually creates real value, where automating that task actually makes a huge difference, because it just wouldn't work at such a small scale if you're doing manually. So in your experience, why? Maybe I don't know. I don't know if I can frame the question better, but why you think it's fairly easy to frame a lot of problems using machine learning?
I think probably because majority of the things that we need to do in finance start with a human, and so this is actually a common journey for different product features inside of Monzo. That like, let's take a simple example that. A customer is expecting a refund on a transaction. And at the very beginning, we didn't have any ways to report that. So people would get in touch with us via the chat screen. And then maybe the agent would have to go and search for some information about like, what should I tell this customer? And so it always begins that we discover customer problems by them getting in touch with us, by them struggling with different things. And so in my mind, any time you have a problem where like a human can kind of make a decision in like 1 or 2 seconds about it, and in doing so, they're generating data about the decision that they made, there's a good opportunity for machine learning. So in this case, as a direct example, we want to make sure that all our agents are giving customers like clear information. And so one of the things that we do, which is common practice, I've seen even other companies do this as well, is we have a knowledge base that has all these like pre-filled responses that they can give to customers. So like, for example, the process of like how to replace your card, or the process of like, oh, you need to wait a few days if you're expecting a refund. And so we don't want these agents to have to type all of these words out. So what they end up doing is they use a little shortcut that pre-fills that response, and then they personalize it, maybe say happy birthday if it's your birthday or something like that. And then they send it off to you, and it makes it so fast for them. But if you look at it from a machine learning side, now we have something that a customer said. We have an agent who's looked at that and picked a shortcut to send back to you.
Oh, yeah.
And so now what we did is we built a system that when a customer writes in, we recommend these shortcuts to the agent. We say, hey, these ones look like the relevant ones, because we have now probably in the order of like 1,000 of these responses. So that's not that system. I'm dying to improve it, but it's a good example of the type of systems where you're basically looking at work that humans do, and that the fact that as they do their work, they're making decisions, they're logging data about that work, and then you automate it later.
Makes total sense.
Yeah, I'm wondering how you decide on, like for that use case, it seems pretty clear that you would want to use some kind of recommender system. But in other use cases, I imagine there are a bit of, it's like not so clear if you want to use just rule-based or if you want to use machine learning. And so how do you go about deciding which one you're going to use?
Yeah, so this plays into like the fact that we're a very small machine learning team right now. And so generally, whenever there's an opportunity to use machine learning in a certain part of the business, my actual first recommendation was like, let's put a rule engine in place, right? And that's kind of for two reasons. One, because you don't need a machine learning person to build a rule engine. And we definitely have way more engineers in the company than machine learning folks. And then the second bit is that sometimes that rule engine is good enough, and then we can focus on where machine learning will make the difference, sort of unlock a problem. So the only things that I factor in there are like, is it possible to write a rule engine? So with text, it becomes really hard, right, to write a rule engine. But an example of a rule engine that we use today is when a customer does get in touch with us, and they come from a specific help article in the app. Like if you go and find a help article that is about changing your legal name, and then you click chat with us, we will then use that signal as a rule to send your chat to an account management specialist. So there's always, effectively, we start with a rule engine everywhere. And then the question becomes like, will machine learning add value here? As in, will it make a huge difference?
Yeah, that's such a great way to look at it.
I think that's a smart way to approach it too. Like, develop some sort of baseline, some sort of heuristic, something that is like well established. Some like for in the typical use case that I'm familiar with, it's like some feature about a disease, and you could use it as like a baseline. And if you can't beat that, then it's probably not worth investing all this time, developing such a big model if something so simple can really solve that problem. And that happens more often than I guess like I would expect, if that makes sense, because oftentimes something really simple can have huge impact. But the downside to that is that it doesn't go so far. Like I've had a lot of challenges where you reach it does okay to solve the problem, to automate some tasks, but it's not as performant as you would like it to be.
Yeah.
But so then you start doing all this extra stuff to try to make it super performant. But then I don't know, sometimes a good baseline goes really far.
Yeah. And to be honest, the extra value of that rule engine is that it often forces the teams to start logging data about outcomes. And so it creates your data set that you need for machine learning, right?
Nice.
Usually if you're starting from scratch, there's the whole, where's the data? Do we even have it? Like, are we labeling these things? Do we have the outcomes? And once we build a rule engine, an outcome there is to get that data that we need.
So one of the things that we're curious about is, you mentioned that you guys have a small machine learning team. So how does that work? How do you go about structuring the way that you guys tackle projects, and how does that relate to, I guess, MLOps? Because to me, MLOps is not just a technical thing; it's also cultural. It's how you organize your company. So can we talk a little bit more about how you structured the team and how that affects your day-to-day projects?
Yeah. So right now, inside of Monzo, we have data science as a discipline of the organization, and there are probably around 40 people across all of data science. But then data science breaks down into several different areas. So one of those areas is product analytics, understanding our customers, building dashboards, KPIs, evaluating experiments, and that's a super important part of the business. Second area is all of the domain specialisms of banking. So people who understand credit scoring, people who understand finance, and they use their data skills to build up the numbers that we need there. And then the final area is this data engineering. They build our platform and tooling, but primarily for our analysts and product data scientists, and then machine learning. So machine learning, there's currently 3 of us, soon to be more. And
yeah, you're hiring, right?
We've closed the ad because we got so many. I've been on hiring calls I think I've done about 20 hours in the last.
No way.
Weeks. Yeah, it's been crazy.
Awesome.
So the machine learning team is, in terms of the spectrum of data science work, we sit more on the building systems side of data science. So what does that mean in practice is this is a lot of my thinking here was shaped by my experience at other companies and by consulting with other companies and talking to different teams. And one of the most recurring frustrations that I hear is I've trained a machine learning model and nobody has shipped it for me. And I'm waiting months and I'm trying to convince people, please ship my model. And that is one of the frustrations I've heard so many times from machine learning folks.
Yeah.
That when I was setting up the team at Monzo, I was like, that's the one thing I don't want to happen here. I don't want us to be training models and then chucking them over a wall and at some other team to put into production. So that plays straight up into MLOps. On those 2 fronts. One is that my team needs to upskill. They need to learn, right? What does it mean to put something into production? They need to factor that in when they're training their models. Is this something that could be shipped? Or am I just going crazy with all sorts of data that we would never have in production? And then the second side is the MLOps specific stuff, building that tooling that makes it easier for us and faster for us and safer for us to get those models out. So if I rewind to when I joined Monzo, there was one big neural network that was in production already, and it was powering the article search in the app, and it was great that that model had been shipped, but getting that model into production was a nightmare, and it was very difficult.
What were just out of curiosity, what were some of the challenges there? Was it size, latency, things of that nature?
It was so the Monzo backend is on AWS and it's running on Kubernetes. Primarily, it's Go microservices, and our main data store is Cassandra. This neural net was written in PyTorch, and we had no Python in the backend at all. So what they had done at the time, which, to be honest, I don't fault them at all, because getting this thing working is the most impactful thing that they could do. With they built a small Flask microservice that was like wrapped with like a Go layer, so that I could talk to other services.
I get that.
Yeah,
I get it.
And what it would do is, so when it was starting up, this service needs to have embeddings for all of our help articles, and it would compute that while I was starting up. So just starting up the service would take like 20
Slow.
minutes, right?
Yeah.
And then, yeah, so it was kind of a black box. It was a black box to other engineers. And this is the type of risk that I really wanted to avoid, because if that thing went down and the two of us were like on holiday, like it would be trouble. And, we'd have to be called up and, hey, how can we start this thing back up again? So our journey has been starting from there, where, to be honest, like that's actually is the best place to start, which is get something working, get something over the line.
Yeah.
And then work your way to making it quick and easy and safe to do that again and again and again.
And that's a common strategy, right? Like, I'm thinking about like writing algorithms, right? Start with a brute force algorithm, get something that actually works, that's correct, and then try to, optimize it. One more thing I want to dig a little deeper into. So I think it's important that you were bringing up this fact that like you want your team to learn how to pick up some of these skills, right? So you want to minimize that bus factor. You want to share that load, share knowledge. How have you gone about that? Because I find it's a challenge. Like even in my day-to-day work, that's not easy to keep everyone up to date with all the things that you're doing. And sometimes it just doesn't make sense. Like I don't need to worry about what they're doing so much, but it's helpful if something does go wrong, someone leaves, or which is that happens. You have to now pick up that skill or pick up that project. Yep. So how have you addressed some of those challenges?
So from the team perspective, again, this sort of anchoring on my previous experience, where in different orgs, sometimes you have like a one-to-one mapping between data scientists and projects. And that's a huge risk, because then you have that one person who leaves or goes on holiday, and like that project stalls altogether. So that was one thing that we try to avoid. And as an example of that is, and collaboration is still hard in machine learning, right? Because most of the work is happening in like people's heads, right? And like the code that we write is not really, it's not like a traditional engineering thing where like two engineers can say, I'll write this bit of the code, and another engineer say, I'll write that bit of the code. Like, no, in machine learning, you're like going through hypotheses, you're like trying things. So the code is nearly like, you can even throw it away. So one of the ways that we tackle this is therefore to like take a problem family, and then we each work on one of those, right? So as an example, last year, we were shipping a bunch of text classifiers, and we needed to detect all these different topics that our customers were talking us to about. And so one of the ways you could treat this is like a huge text multi-class classifier, right? One machine learning model. And instead, what we did was we broke it into, rather than let's train one model that can predict like 15, 20 topics, let's break it up into 20 models that can each binary classify one topic.
Oh, nice.
And so that means each of the folks in my team can like pick up one of these models. We're all working on text data. We're all like, anything that one person does to like denoise the data or whatever can help someone else. And at that time was when we did some early investigation into transformers, which was then called like PyTorch pre-trained BERT or whatever it was called previously. And so we ended up with two pipelines. One pipeline which was generating a text data set. So you'd say, this is my label, and it spits out a data set. Another pipeline that, given a data set, would train a BERT model, fine-tune a BERT model, right? And so we managed to get collaboration because we're both like, everyone in the team is like using the same products, if you want to call it, but they're each using it to like train different models. So that's one way that we do, is like we break up big problems into like related problems. And then the second thing that we do, which again, I guess plays more into the MLOps space, is look at what is it that we're doing over and over and over again. And that's painful, right? And so an example there is when way back in the day, when we would ship a model into production, we would put it into an S3 bucket. We'd, put the model artifact into an S3 bucket. And so we had to ensure like S3 credentials were set up properly and all that jazz. And it was a little painful, right? So we built a model store service and a little CLI tool that when a machine learning scientist to train a model, they do like Python upload this model and they get prompted for all the information that they need to add, like what's this model for and all that. And then under the hood, it takes care of all the hard stuff, like put it into S3 in the right place, make sure that it's available to other services when they start up and all that stuff. And critically also, this really helps me, is it logs data about the fact that we've uploaded a model into production so that I can see it on our nice, pretty dashboard. And so, yeah, like that's the second side is what are we doing over and over again? And can we replace it with a tool?
Wait, do you have something that, like you just said, on that nice, pretty dashboard that will tell you everything about all of the different pieces of the puzzle and when they're being updated or when they're being trained and who's training them, all that metadata there?
Yeah. So what it has is total number of models we have in production. And then right beside it for each, so basically the way we categorize our models is by domain, right? So let's say one domain is predicting a type of fraud, right? Or another domain is like predicting whether this text is about requesting a bank statement. And for each domain, then I can see when was the last model uploaded. And then you scroll down and it has some more information about running training pipelines and all that kind of stuff.
Are you also having like the monitoring of these models on that dashboard, or is that something else?
That they usually end up being separate dashboards.
Okay.
To step back a little bit there, so Monzo's analytic infrastructure is that, and there's like some blog posts about this as well, but effectively we run all of our production infrastructure in AWS, but then all of the data that gets logged there gets stream appended into BigQuery in Google Cloud. And then we write a bunch of SQL using dbt. And that gets run at different intervals with Airflow, generating these different tables effectively, which then get visualized in Looker. And so Looker is used across the entire company for everything from like high level KPIs, how many customers do we have, that type of stuff, all the way through to experiments. And so when it came to picking a place to surface information about machine learning models and their performance, what better place than the place where everyone else in the company is looking, right?
Yep. I think that was really fascinating what you put in that blog post. And we'll link to all your blog posts because you're pretty prolific on your GitHub. So we'll make sure to put that all in the description. But in that blog post, you talked about how it's like, why am I going to bring on another tool that the whole company isn't familiar with when we are already using this? So let's see if I can make what I'm trying to do work with what we already have, so that there's no like, oh, these guys need to relearn it, or we need to translate it into this other tool and from the tool that I want. Makes complete sense on that aspect.
Yeah,
or just not reinventing the wheel too.
Yeah, I guess in this kind of, I know it's different at different companies, the thinking behind this, but in my mind, if we can even tweak an existing tool for a new use case, it's easier than bringing in a new tool. Because the more tools that we have, the harder it becomes to manage them and to know all about them and effectively maintain them, and that applies also for a lot of our MLOps tooling that we have under the hood, all of the different things that we built. So like model training, pipeline automation, model stores, feature store. Under the hood, they're all using the base technology that we use to ship features in the app as well, right?
Well, I was wondering about that because when I talked, I think it was like 2 or 3 weeks ago, I talked to Timothy Chain, and he was saying how like what we're seeing in the maturity of the MLOps space is actually, it was Nathan. So I was talking to Tim and Nathan, and Nathan, I think, said this. He was like, you'll see that the structure of the MLOps infrastructure or the machine learning infrastructure is very much like what you have set up, right? So you've got something that works with what you have, and you've brought it on, you've maybe built some things yourself, you've got things working, you've proved out a business case for it. But what he felt would be the way forward as we start really advancing is you're going to see people that say, okay, now I want to stop spending so much time on the infrastructure part, and I'm just going to buy something. And of course, big disclaimer, these guys are investors, right? Yeah. So they hope that is the way forward so that these tools that they've invested in can start making money, I imagine. And if Tim or Nathan, if you're listening out there, hopefully you do make that ROI. But I'm wondering what your take on that is. Do you feel like there will be a point in time where you say, okay, you know what, we just need to go out and buy something because this now is taking up too much of our time to try and like integrate it?
Yeah, that's a tough one. So there's some weird things on that front that I've seen so far. Some of the companies that I've spoken to who have bought these new MLOps platforms, I feel that they're buying them to kind of like leapfrog into being able to be more productive with machine learning. So it's not that they've reached a point of saturation where they're like, oh, this is too much for us. They're like, wait, we actually can't do this at all. So let's buy this platform to start doing it. So that's one pattern that I've seen in some companies. Then the second point that I've seen is that most of the companies across the industry that we look to as like role models for machine learning, I don't know, places like Spotify, places like Airbnb, Pinterest, Uber, Google, like I don't see any of them reaching that point, right? Where they're like, oh, this is too much for us, right? I actually see them doubling down on investing into the tooling that they have for shipping machine learning. And so, you know, I know there are a lot of ex-Uber AI folks who are setting up ML platform companies, and you know, a lot of them are in our community. But what I'm seeing is that the companies where we use them as role models for ML, they're the companies that have invested into that tooling and into building it themselves. So because ultimately, having employees who are productive in your company is like your value, right? And
spot on, man.
Right. And so what that means is that the companies today who are shipping machine learning and doing it for real, and I mean, I by that I mean not doing it for research or not doing it for blog posts, right? But like actually shipping it for real. Like they're the companies that are thinking about how can I make my employees more productive. So the similar mentality exists at Monzo for our engineering org. We used to have a team called Engineering Effectiveness, and that was their whole remit, was make our engineers more effective. Mm-hmm. And so now we have several teams who look at different angles of that problem in terms of storage, in terms of build and stuff like that. And I do feel that machine learning is like a few years behind. Like that's basically the recurring discussion between DevOps and MLOps. But yeah, a lot of the companies I see who are doing well in this space are not buying.
Yeah, that's an interesting point. That's very interesting.
I think it makes sense too that some of these bigger companies don't really buy. One, they have the either the money, right, to pay people to build these things. Maybe they just can also afford like exploring things that don't really pan out and don't end up becoming like this big money maker, but serve some purpose. Like, I'm thinking like Google, right? There's a lot of failed projects that they do, and they can afford to do that. They can try out things and it not work. But a smaller company is not in a position to experiment with maintaining a huge infrastructure that may be fairly complicated. So in those situations, I feel like it makes more sense to start considering, like you're saying, what's like, how can I enable the people that I'm asking to do something to actually do good work? And for data scientists, maybe the smart decision is to use something that is enterprise, that is ready to go. That way you don't have to do too much boilerplate or write too much boilerplate code and do a lot of these things maybe that they're not trained to do. And maybe the company is just, that's not their focus. If they're, a finance company, they have engineering, right, to support a lot of the things that they're doing. But if that's not their primary domain, it makes sense not to, waste too much time trying to be something that maybe you don't have the bandwidth, the resources, the expertise to do. And I think that's fair. But I think it's a good point that you said about or it meant not a good point, but like a good observation that a lot of these companies, when they don't have that expertise, they buy something to kind of replace that. But I don't know how well that works. I'm really curious to see, like, does that actually end up making your engineers and data scientists more effective? Because some of these tools, while they are maybe they I guess fairly mature, there's still, there's a lot of things that are changing in this space. How far that goes. But yeah,
especially this week, right, with all the AWS announcements going out. Having said that, I'll caveat it with one thing. So there have been a couple of times at Monzo that we have started using tools that we didn't build from scratch in-house. The two examples I would highlight, one is DBT. We're using their open source version of it, and it did the reason why we started using it was because we saw that it would have a huge gain on our productivity and collaboration across this growing team of data scientists. And then the second one is the Transformers library. And so before we were training text models from scratch. And so, very long pipelines and a lot of code and a lot of difficult stuff to maintain and tweak and know that it's working well. And when all these pre-trained models popped up, it just made our lives easier, right? So that's kind of one entry point for stuff that we have adopted is we go, oh shit, this thing is going to make us a lot faster and more efficient. And so it's less about giving us the capability to do something, but more about giving us like the productivity when doing that thing.
And do you guys have I want to get into infrastructure, but I know we're getting kind of low on time and I want to touch on that. But before we do that, maybe last question here. You talked about these like engineering optimization teams. Do you have that for the machine learning team also? Or is that kind of your job? Is that what you were saying, how it's like a little bit in the back burner?
Yeah, it's been our job. And I've seen this as a pattern in a lot of companies that like machine learning people are laying the track ahead of the train, right? And so like, and sometimes it's a frustration for some companies where machine learning people are spending majority of their time like enabling their own work to happen.
So common.
Right? Common. So, but the key thing that I've seen is that right now we are the best in terms of knowing what our problems are. And so if I look back on this year, for example, we spent Q2 shipping a bunch of tabular models and they were working really well. And then we looked at the patterns that we had and we said, oh, wow, like a feature store would really help us here. And so in Q3, we built a feature store. So we kind of have to do this trade-off as a team of like platform investments versus, like other types of investments. I think as the team grows, this sort of specialism will become part of the team.
Yeah, that makes sense. So let's talk about the infrastructure. And I would love to hear about basically from inception, from an idea, you touched on it a bit, but maybe go a little deeper, just like when you realize, hey, there's a problem here, or there might be a problem here, you do this rules-based test, you see like, hey, if we put some machine learning on top of it, it could make things more interesting. So how do you then start with that and take it and get it across the line?
Yeah. So, and this is where you'll hear me being opinionated, as if I haven't been already, right?
I love that. We don't mind that at all. Yeah.
So often we'll start, obviously, with the data and prototyping ideas in notebooks. And I know that notebooks are a point of great debate in the community.
Yeah, you said that in your blog post too.
Yeah. So my view on that is we use a notebook in the same way that engineers use a whiteboard, right? We're mapping out ideas. It's code that we'll throw away. We care about the results. We don't care so much about like the code itself. We care about the insights. From there, once we've sketched stuff out, we will typically write a pipeline in Python that will say train a model or create a data set. I touched on those earlier. And those will get run in the Google AI platform, where effectively you're submitting Docker containers to run. The way we've made that a little bit easier is that we have a cookie cutter template that when a data scientist wants to make a new pipeline, they just run a command. It gives them all the boilerplate. They don't have to write Docker files or any of that nonsense. Once we train these models, they will get stored in GCP. And that's when we will often have to make a decision. Is this good enough for prod or not? Maybe we'll have several candidates. And these are the type of things we'll talk about in the team meetings. And when we have something that's good for prod, then there's that one command that I mentioned earlier, which sends something into our production model store across our two environments, staging and production. And the same person who trained the model will then build a Python microservice to serve that model. And again, it's the same concept of like one command. It clones a template and it fills it with boilerplate. And so the job of the machine learning person then is effectively to fill in the predict function. What does that look like? And what does it have to do? And we don't take any strong views on like, we only use this type of framework. We try to keep that open. So we've shipped PyTorch models, scikit-learn, GenSim, quite a wide range. But the key decision that we made there is that our Python microservices their job is to do the predict. And they don't do anything else.
Yeah, it's like a little function as a service, right? They essentially just do one thing and one thing well.
Just predict as a service, basically, right? The main reason behind that is that Python is not the like primary like mother tongue of our production infrastructure. So I mentioned that we write Go services. And so all of our engineers use Go and write Go and understand Go and can debug and maintain Go. And so it's very easy for them to be given a service where it says, look, if you send this data to the service, you'll get a prediction back. And they don't need to know that it's Python. They don't need to know anything else that's happening under the hood. And we can worry about that. And So then that final step is either some of the more senior folks in my team know Go as well, and they can just go and build stuff and integrate it end to end.
They can just go.
Yeah, they just go, right? And Go and Python are actually very similar languages, right? I mean, you can say like Spanish and Italian, but they look very similar. If you know one, you can learn the other. And
yeah, I love Go. Side note,
right? And I didn't know it before Monzo. I've learned it all in my time here. So that's the final step of like calling the predict function from the right place of our system. The only last thing that I'll mention, this is something that I've also blogged about before, is that there's this recurring problem in machine learning of training a model, getting some numbers, and then do those numbers look the same in production? And so what our typical journey will look like there is if we have a brand new model or even a newly trained model for an existing domain, we'll put it into production, but we'll put it into this, like what we call shadow mode, or I know it goes by other names as well, where that predict function is getting called, but it's not getting acted on. And so It's just logging data. And then all of that data just feeds right back to what I described earlier, which is our analytics stack, where we'll write some SQL and surface it in Looker.
So two things.
Go for it.
Sorry to jump in. That come to mind instantly is, A, how do you deal with reproducibility? Because I know banks are under a lot of scrutiny, right? Like fintech is one thing, but then once you're in a bank, there's a lot of regulations. And especially when you are doing machine learning, I don't think there's so much regulation now, but in the EU, they're talking about like bringing down the hammer. Yep. So how do you prepare for that? And how do you make sure that you comply with all of that?
Yeah, that's a great question. And it's also a space that's moving, as you mentioned, quite fast. In my mind, this breaks down to like what area of the business are we shipping models for? So, for example, shipping a new text classifier that helps our customer service agents get like saved response recommendations, that's kind of a low risk area. It's a recommender system. It goes to a human who's internal. They make the final call. And so these flavors of machine learning problems aren't usually attended to in such detail by regulators. Whereas on the total opposite end of the spectrum is we have a separate team that is exclusively focused on credit scoring. And, shipping a credit scoring model is kind of that's as hard as it gets, right?
Yeah.
Because if you ship a credit scoring model, you're not going to get a signal back for like 12 months on how good it was. And so they go through a really like fine-grained process to replicate, validate their results, report on them. And this plays straight into the typical structure of a bank where you have several lines of defense, as they call it. So you'll have the front line, which is the people doing the work. And you have the second line, which are the people who check the work of the front line. And you can go back further there. So with these models that are more critical, anything that's making decisions about financial crime, signups, whatever, anything like that, then we have a much stronger focus on the data. The only caveat, because I know that replicability is like a big topic in our community, is that it's not so much about like, can I definitely replicate this, right? Like, can I rerun the code? It's more about like, did I follow a structured process that shows that I was like doing this safely and in control and not just like making ad hoc
cowboy
decisions. And actually, I like that name. I'll bring it back into Monzo. And then being able to show that we monitor it, and that we are aware of the customer impact if there is any, and that we have ways to find out when things are going wrong.
So one thing that I wonder about is like, do you have any ethics people on the team because you're talking about these credit scores, and this is what I would consider like high stakes ML. You could potentially ruin somebody's life, right? Like if you give them, well, maybe not ruin it. Yeah, maybe you could. And also like with a loan or something, if you're deciding who gets a loan and who doesn't, and this is just a quick side note, like another passion of mine, and I've been doing another podcast on AI ethics, and this comes up a lot. Like this is really a big thing when you start getting into machine learning. You put it perfectly. Like if it's just a text classifier, so yeah, not that big of a deal. But if it's something that is going to decide whether someone gets to advance in society or if they have good credit, bad credit, that's really playing with fire in my mind.
Yeah. So we don't have anyone whose job it is solely to look at this. This is like a collective responsibility. And maybe the one example that jumps to mind is what you mentioned earlier about trying to sign up for a Revolut account. And for transparency, I have no idea how their systems work. But at Monzo, we do not use machine learning to like match your face with your face in the document. And what happens instead is you submit everything and we pass that on to a identity verification provider. And they will manually review this stuff. So it's one that stands out to me because specifically image classifiers are one area where you will see the most recurring headlines around bias, around race and gender disparities in these classifiers. So I'm not saying that Revolut does this in any way, just to be 100% clear. But what I am saying is that we don't. And that's an example of a problem that we know machine learning could, we could try it, but we've decided not to because it's an area that we don't feel comfortable. We don't feel that it would be ethical to reduce someone's sign up to a classifier of that in that way. Instead, what we've been exploring is trying to make customers' lives easier in signing up for these things. So I'll tell you like one specific example. When customers sign up for a Monzo account, they need to take a photo of the front and the back of their document. And one of the common errors is that people upload the photo of the front twice, right? And so that's also an image classification problem. And actually, by classifying that, we can give feedback to a prospective customer within seconds rather than sending that off and asking them to wait hours for a human to review it. So that's the angle that we take, is like, okay, this is a problem that could help our customers, it could help us, it could reduce the workload that we create inside of the company. And it doesn't really have this potential of, going severely wrong. So it's definitely a point that we keep in mind, but I see it as a shared responsibility across the team.
Awesome. So the last question that I was wondering about on your infrastructure, and this gets into, it seems like you have so many different use cases. Some are potentially streaming, like you just said, if you are looking at this image classifier and maybe something pops up that says, this is the same front of the picture that you just took. Are you sure this is the back or whatever? Like maybe breaking down how the differences between streaming and batch. But before that, maybe you can explain why the two clouds. Why are you using GCP for one and AWS for other things?
Yep. So that's a decision that predates me. But my hunch there is that it's because of, if you look at the most senior people in the company who were starting it up 5 years ago, our VP of data was at Google before, and our VPs in engineering worked at companies that were working on AWS. So my hunch is it's that. But the main benefit that we've seen from it, particularly in the early days, and is that by having two clouds, you create a blast radius around one cloud, right? So like effectively when a data scientist would onboard, a year, 2 years ago, we could say, you know what, you can actually break everything there in GCP because it won't affect our customers, right? It won't stop the app from running and anything like that. And then we can even make our production infrastructure much more secure because like very few people have access to it, and we can really lock it down. So that's one of the main benefits that we saw, which is that, like delete that table, right? Nothing bad is going to happen. Or the worst that's going to happen is someone is going to pop up in our Slack channel going, hey, what happened to this table? And we'll go, oops, we'll put it back. So it's been good. And plus then I get to learn about both of those clouds.
Mm-hmm. And so as far as the real-time, like streaming versus batch, what are these different use cases, and how do they differ, if they do at all, when you're doing things?
So usually for batch now, we can run it fully in GCP because of the nature of batch problems where, say it will be looking at the last day of data and running predictions on it, or looking at all the customers who did X and running predictions on them. It makes it much easier to access for data scientists, including those outside of my team. For the streaming, I guess under the hood, it's sort of two use cases. So we could maybe call it live predictions, where one is it's a system that is consuming events from streams and then running predictions. Or the second is a system that is receiving live RPCs or HTTP calls to return a prediction. And those are the ones that require that second half of the journey that I mentioned of like creating a microservice and shipping it in production. In general, we've broadly been biased towards that one because that's where we tightly integrate with the product, more so than the batch stuff. Even though I know that in a lot of companies, the batch pattern is probably the most common one.
Yeah, and a lot of things can start off that way, right? Like if there's no, latency constraints, then you could just do things offline in bulk. But after a certain point, like like you were mentioning with some of these applications, I guess that just doesn't work. So how do you address those issues? Do you guys? I think the original question, sorry, Demetrius, was about like the different, like how do you have batch, you have streaming, but how does that affect your infrastructure? So are you doing some things on AWS? Some things on GCP? Like how do you choose which one? Because sometimes they have pretty much like the same service, right? Like a managed instance of something. So how do you go about, picking those things off? And that's just the last question, sorry.
Yeah. So the summary would be train and batch in GCP and then serve and live in AWS. And that's just because of the historical reasons of our infrastructure. The one thing that I would add to that, which happens on the live side, is that if there is a service that does some sort of inference that already exists, right? Take these like very popular areas like sentiment analysis or these sort of things that like AWS offers as a service now. That saves 3 months of my team's time. We don't need to train a model. Just call that API. And so that means that the problems that we're tackling are the ones that are specific to us, rather than generic problems that are now turning into APIs that these big tech companies offer.
Yeah. Awesome. Well, Neal, we had a really great time. We talked about a lot of different things. On a high level summary, we've talked about a little bit about Monzo, about the work that you guys are doing, the scale, some of the challenges you guys are dealing with, the different ways you frame machine learning problems. We talked about teams, or how that plays into MLOps, solving problems by breaking them down. A lot of really great things. Too much to summarize here. But to close, one thing I would like to ask, and this is something we haven't done this in a while, but if you were to give the MLOps community one piece of advice, it could be something that's just in your mind right now, something that like you were thinking about earlier. But what's that one thing that, I guess, that one little piece of nugget of wisdom to close us out?
Yikes. Putting me on the spot here.
Yeah, sorry. Yeah, we haven't done it in a while. Anything.
Yeah,
Could be
I
anything.
have one. And
Love it.
So as you've seen, I've been following along with the community a lot, and I really enjoy it, to be honest.
Nice.
What I'm seeing in a lot of the propositions for ML that are coming out from new MLOps companies is like, worry about this problem, worry about that problem, worry about that problem, right? Like, and so all of these MLOps companies are like saying like, oh, if you're not like monitoring your features, then you're doing it wrong. If you're not doing this, you're doing it wrong. If you're not doing that, if you don't have a feature store, you're doing it wrong. And to a certain extent, they're right. But don't let that stop you from actually just shipping some machine learning, right? And get something over the line first, and then worry about like starting to monitor stuff and starting to make it more replicable and
iterate,
easier to do. So yeah, like I said, the first thing that happened at Monzo was we shipped a huge, complicated, difficult to ship neural net, but they did it, right? And that was the success of that work. And then we made it easier. So don't fall into like analysis paralysis on the MLOps tooling. And yeah, that'd be my little piece of advice.
I think it's very wise, and I really appreciate that.
I will also say,
I was just going to say, we've heard that same sort of like that same advice before, right? To iterate on things just to start. And there's like almost like this like FOMO, right? Like fear of missing out if I'm not doing the cool thing, right? I'm not using the cool tools. But yeah, I think that's a great point. That's really not what's important. Get something done, focus on creating business value, and then take it from there.
Yeah, it was really very similar to what Satish said. I don't know if you remember that, David, but it was like, that's what he was talking about too. And it was like, just because you can't do this thing, do like one part of it doesn't mean you shouldn't be trying to do other parts of it, right? A little similar there. And got my daughter yelling in the background. I don't know if you can hear her. But I was also going to mention one thing that stood out with me on what you said was this idea of a blast radius. That's so good, man. So awesome. And I love that you set it up that way so that you can insulate yourself from mistakes, because we always make them. We tend to do them. That is one thing that I'm going to take with me from this talk for sure. Sweet. And I really appreciate you coming on here, telling us all about what's going on with Monzo. And yeah, we'll see you in the community, man.
Yeah,
this has been awesome.
Thank you for having me, and I will be there.
See you later.
Awesome, and guys. So thank you everyone for go ahead.
No, I was just going to say, we'll link all the blog posts and everything we referenced down below as we do. I did realize after we started, I forgot to turn on the music.
Oh man,
let's start again. Let's
do it again. That was just the warm up.
If anyone, shout out to anyone listening. If anyone's good with that type of stuff to make our videos awesome, please reach out to us. Because me and Demetrius, we suck at this. We just start talking and forget about what's going on. And
but we can put the music in and post it. All right, that's
guys,
it. We're
thank
cutting
you so much for listening. Bye, guys.